Okay, so today we're diving into something kind of unexpected.
Hmm.
Um, we're going to be talking about making gold,
Right.
but not like mining it, right? Like
Yeah.
actually creating it like a medieval alchemist.
Yeah, it sounds like fantasy, but it's really at the heart of how we understand chemistry and how we even do science today.
Yeah, and our guide into this world is none other than Francis Bacon and his work Silverum from 1627.
Right.
Now, Bacon was, you know him. He was a giant of the scientific revolution,
He was a big thinker.
a huge proponent of observation and experimentation.
Absolutely. But it's important to remember that formal chemistry as we know it doesn't
That's
really exist in Bacon's time.
So we're dealing with a blend of like sharp, almost modern sounding insights
Yeah.
mixed with ideas that might seem a little more, well, alchemical to us today.
Right. And Bacon himself addresses this, right? He
Mhm.
was very aware of all the get-rich-quick schemes and scams
Oh, yeah.
that claimed to turn lead into gold.
Of course. Of course.
Yeah, right. And
And he doesn't mince words, does he?
no, he really doesn't. He calls them unsound imaginations
Yeah.
and even imposture.
It's almost like you can hear him saying, don't be ridiculous.
Exactly. But
Yeah.
in the same breath, he says, you know what? I think it might be possible.
Yeah.
I think it might be possible to artificially produce gold. And it's that tension
Right.
that makes him so
So
interesting.
how do we square that circle?
Well,
The skeptic who also entertains the possibility.
I think he was skeptical of the methods, right? He
Sure.
wasn't necessarily skeptical about the goal, but he was skeptical of all these wacky schemes that people were putting forward.
Right?
He wasn't buying the philosopher's stone or anything like that.
Yeah.
But he was deeply interested in how matter transforms.
Okay.
How does one substance become another substance?
Sure.
How do they interact?
Yeah.
How do they change? And this all ties in with his larger philosophy of understanding nature
Okay.
through observation, through methodical experimentation.
And it's not just about gold, right? He also talks about the Chinese being obsessed with making silver.
Right, right.
And he says that it should be easier to make silver
Yes.
from heavier metals,
Yes.
which to me, it sounds completely backwards.
Right, and that's because we have this modern understanding
Yay.
of elements, the periodic table, atomic structure,
Right.
all this stuff that was centuries away when Bacon was writing.
Right.
What he's doing is he's trying to apply reason, observable properties
Oh, cool.
to this question.
Right.
He uses terms like fixation
Okay.
and condensation. These are terms right out of alchemy, right?
All right.
But what he's trying to do is ground them in something tangible, something
Yeah.
repeatable, not
Yeah.
just magical thinking.
Right.
He's searching for that natural process.
Interesting.
Mm-hmm.
So he's got this idea about like metals transforming,
Right?
this idea that maybe you can nudge them into becoming gold.
Yeah.
But does he like try to put it into practice?
Yeah. He does. And this is where things get really interesting.
Okay.
He outlines an actual experiment, right?
Yeah.
And it's surprisingly detailed for the time.
Okay.
He doesn't just say, like, throw a bunch of stuff together
Right.
and hope for the best.
Yeah.
He says you need a controlled and steady heat source.
Not just chucking it all in a furnace.
Not exactly, no.
Yeah.
It shouldn't be the kind of intense heat that a blacksmith would use.
Right.
More like a gentle and consistent temperature, he says.
Interesting.
And he even gets into the specifics of what you need, what ingredients you need.
Okay. What's on the shopping list?
So he says silver is the base.
Okay.
You need quicksilver, which is mercury.
Right.
And then he mentions something called niter.
Niter. Okay. I guess I can't just pick that up at the store.
Yeah.
What is that?
Niter is an old name for potassium nitrate.
Okay.
You probably know it better as like a main ingredient in gunpowder.
Oh, wow. Okay.
Yeah, it's a powerful oxidizer,
Which means,
which means it reacts very easily with other substances
okay.
and often releases a lot of energy when it does that.
Interesting. So it makes you wonder if that was part of his thinking, right?
Right.
Like this energy could be what transforms the metal.
Exactly.
So it's like we're trying to decode these ancient experiments with our modern knowledge.
Yeah.
But did any of it actually work?
Yeah.
Like, did he stumble onto some chemical truth?
He definitely hit on some very fundamental concepts that even today are still at the heart of chemistry,
Okay.
like temperature control, for example.
Right.
We know now that even tiny changes in temperature can
Yeah.
completely change how a reaction's going to go.
Right.
And Bacon realized how important that was.
Even back then.
Yeah, even though they didn't have, the same kind of thermometers and things that we have today.
It's like he had this intuitive understanding of how delicate the whole thing was.
Yeah, definitely.
Okay.
And then there's this other idea. He talks about a spirit. being released during these reactions.
The spirit.
Yeah, and today we would look at that and think, okay, he's talking about gases.
Okay.
Gases being produced, things that we might not be able to see,
Right.
but they're still fundamentally changing what's happening with those materials.
So even then they understood that it wasn't just about what you could see,
Exactly.
but what was happening at a much smaller scale.
Absolutely.
Interesting.
And here's something else that I think is really interesting. He says these experiments could take a really long time.
Okay.
He suggests at least 6 months.
6 months.
At least.
Wow, talk about patience.
Can you imagine doing an experiment for 6 months?
I can barely wait for, like, my toast to pop.
Exactly. We want instant gratification.
Right.
But imagine if we had that kind of patience.
Yeah.
What kind of scientific mysteries could we be unraveling?
That's a good point, actually, yeah. Right. Okay, so I'm sold on the patience thing. But there's one more thing I wanted to ask about. He mentions adding what he calls an oiled substance.
Right.
To make the gold smooth and, like, pliable.
Yeah.
What's that all about? Was he making jewelry on the side?
Maybe. I love that image.
Right.
But, it actually says a lot about his whole approach.
Okay.
Because he's not just thinking about, oh, I want to transform this metal into that metal.
Right.
He's thinking about what he wants the final product to be like.
Okay. To have a use.
Exactly.
Yeah.
And that's an idea that's just as relevant in a lab today, right?
It's true. Yeah.
That's the outcome we want. What are we trying to build here?
It's a good point.
Yeah.
So we've got Bacon, our protochemist here,
Mm-hmm.
really documenting these experiments, thinking about the details,
Yeah.
even like reaction time, what he wants the final product to be like.
Right.
It's all very impressive, but like, did it actually work?
Yeah.
Could he really make gold?
As much as I admire his approach, I mean, it's Bacon, right? He's a really smart guy. It's unlikely that this specific experiment actually made gold.
So no secret formula hiding in plain sight?
Not quite, no.
Okay.
And it comes down to what he was actually trying to do.
Okay.
So, like, to really transmute an element, right?
Yep.
To turn lead into gold, you'd have to change the nucleus of the atom.
Right.
You can't do that with just heat and mixing stuff together.
Yeah, it's not like baking a cake.
No, exactly, no.
Okay.
That's like nuclear physics, right? With
Right.
forces and energy that, 17th century science
Yeah.
had no concept of.
No, of course not.
Right.
Okay, that makes sense. But even if he couldn't, like, will gold into existence,
Right.
it sounds like he was still onto something with this whole approach.
Yeah, oh, absolutely.
Okay.
I mean, in a way, this experiment, even if it didn't make gold, it's
Yeah.
like a perfect example of the scientific method.
Okay.
Like its early stages, right?
Right.
He starts out, he knows what he wants to make gold.
Right.
He thinks about it like, okay, what has to happen for one substance to become this other substance?
Right.
And then he designs an experiment to test it.
Yeah. And he's careful about it, too.
He's methodical.
Right. He's controlling what he can control.
Exactly.
Taking notes.
Right. And you know what's funny?
What's that?
That same way of thinking, that process,
Yeah.
it's still relevant today, even outside of a science lab.
Oh, absolutely. Yeah.
Like, think about a tech company, right?
Okay.
They're trying to make a new app. They have a goal.
They have something they want to solve.
Right. They have a problem. So they test things out. They try stuff.
They gather data and all that.
Exactly. They're iterating, experimenting, really.
So really not that different from our friend Bacon.
No, not at all. Or even like a chef perfecting a recipe,
Oh, that's a good one. Yeah.
trying different ingredients, different temperatures, cooking times.
Yeah. Yeah. They want that perfect flavor, that perfect texture.
Exactly. They have a goal in mind.
Right.
And they're working towards it. And that's really the cool thing about Bacon's legacy here. He was doing alchemy, but he was thinking about observation, about experimenting.
Right. That systematic approach.
Right. And that's influenced how we solve problems.
Yeah. In so many different areas.
They're centuries.
It makes you wonder, like, if Bacon was around today
Right.
with all the technology we have,
Yeah. What would he be doing?
what would he be working on? What could he discover?
It's really exciting to think about.
It is. And I think that's a good place to leave it for today.
Yeah.
If you want to learn more about Francis Bacon and his quest to make gold, check out the show notes for this episode, where we'll have links to more information. Until next time, keep on learning.